Hello, I'm Dr. Papia Bhattacharjee. In this problem, we have to determine the continuity of a function on a closed interval. And the function is right here, x squared minus 4x minus 5. And the interval is -1, 5. So you have to figure out whether the function is continuous inside that interval. So let me remind you, what does it mean by a function being continuous on a closed interval? Say the closed interval is some a comma b. Okay, so first we have to make sure f is continuous inside the open interval. So everywhere inside the interval. So first point is f has to be continuous in the open interval AB. And then, since we have to consider the endpoints, we have to make sure that the limit of the function as x approaches a. Now let me quickly give you an idea what's happening here. Here is a, here is b, and the function is continuous inside AB. And then you have to make sure that the function value at a actually matches the limit. But notice that we are only considering the graph of the function to the right hand side of a, not to the left. So we don't care about what is happening to the left side limit. We only care about the limit as x is approaching a from right hand side. And that limit has to equal the function value at a. Similarly, third property has to be for b. So when we are considering that endpoint, we have to make sure that only the one-sided limit, the left-sided limit, as x approaches b from left, has to equal f of b, the function value at b. So that's the definition for a function to be continuous on a closed interval. Now let's go back and solve our problem. Our function is given as x squared minus 4x minus 5. Notice that it is a polynomial. And since f is a polynomial, we know that a polynomial is continuous everywhere on the entire real line. And therefore, it is going to be continuous on every closed interval. So f is a polynomial, which means that f is continuous on -1, 5. So because it's a polynomial, the answer is pretty straightforward. But still, why don't we see how all these three conditions are satisfied for this function? So number one, again, since it's a polynomial, we know it is continuous on the whole real line, and therefore it will definitely be continuous on any open interval of the form a comma b. So f is continuous. In this case, our AB is -1, 5. Next, check the limit. Let's see what happens to the limit of our function, and the function is x squared minus 4x minus 5, as x is approaching the left end point, which is -1, from the right side. So how do we evaluate this limit? Notice that this is a polynomial function. There is no denominator, so we can just directly substitute and see if we get a value. So just directly substitute -1 to the function. So we get -1 squared minus 4 times -1 minus 5. So this is 1, this is plus 4 minus 5. So this is 5 minus 5, this is 0. And see what I did? I just plugged in -1 in the function expression. and therefore this 0 is going to be the function value at -1. So the second condition is satisfied as well. So let's check the last one the same way. So now we have to figure out limit as x approaches to the right end point, which is 5, but from the left side, so minus. And the function is x squared minus 4x minus 5. Again, it is a polynomial, so to evaluate the limit, we just plug in the value 5. So we get 5 squared minus 4 times 5 minus 5. So this is 25 minus 20 minus 5. So 25 minus 25, this is 0. Exactly the same way as part 2, what I did was plug in 5 in the function expression. So this 0 is the function value at 5. So notice that all 3 conditions for continuity on a closed interval is satisfied by our function, and therefore the function is continuous on -1 and 5. And therefore there is no discontinuity, so we don't have to talk about if the discontinuity is removable or not. Thank you.